Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. In today's lecture, we are going to see how a taper turning process is done on a lathe machine. Now, let us see what is taper turning. In the previous lectures, we have seen what is turning process, and also we have seen how this taper turning process is done. Okay, in turning process, we'll try to understand how turning is done first. So we have to take a cylindrical bar, and if we keep the tool here, what happens? It will try to remove the material from the workpiece. This is the workpiece and this is the tool. So whenever I keep the tool towards the workpiece, it will remove some material. How turning is done? I will give feed in this direction. That means I will move the tool in the horizontal direction so that it will remove more amount of material and it will reduce the diameter of the workpiece. Okay, if we want to decrease the length of the workpiece, we have to do facing operation. That is different. Now, in this lecture, we are going to see what is taper turning process. So taper turning is different. It is not turning. It is similar to turning, but the taper turning will be like this. We have to decrease the depth of cut. So initially we have to start here and we have to go on in an inclined way so that we'll get a taper turn. Okay, we have to move in an inclined manner. Okay, so see the difference between these two. This is also a workpiece. It has some inclination here. Some inclination theta is there. So the workpiece should be tapered in an inclined manner. Okay, so this process is called taper turning. This taper turning has many applications and it can be done in different ways. Now we are going to see the different ways in which the taper turning can be done. Now see here, let us see the basic definition. Cutting the metal on a lathe machine in such a way that its surface makes an angle with the axis of the metal is called taper turning. So this is taper turning. The surface will make some angle. So if this is the central axis, this angle, it will make some angle with the horizontal axis. Okay, so this type of turning is called taper turning, and following are the various methods to which taper can be represented. Okay, according to the top angle of the taper, according to the angle, we can make taper turning. That means this angle theta will be given in the dimensions or standards. According to that, we can prepare a taper, or according to mm per meter, millimeters per meter. That means how much millimeters of depth we have to give for the length. Okay, if this is the length from here to here, this is the length, and this dimensions, the depth, this is also given. This is given in millimeters and this length is given in meters. So how much millimeters of thickness has to be removed from the particular object while doing this operation? This is also given, while sometimes either according to the taper angle is given or according to the millimeters per meter is given. That means the reduction in the dimension per meter is given, or according to the diameter of each end of the taper and length of the taper. Okay, so depending on the particular cross section, we can have one diameter. That means diameter at this cross section, this is A, and diameter at this cross section B. So these two are given. We have to attain a taper between these two cross sections A and B, or by some kind of ratio also can be given. By using any of these four types of parameters, we can do taper turning operation on a cylindrical object. Any one of the parameter is required. Otherwise, we cannot do this operation. Now let us see what are the different types of turning operations or turning methods that can be performed on the lathe machine. Okay, so the following are the different types of taper turning methods possible on lathe machine, and the first one is tailstock set over method. We are going to see all these processes in detail in the coming lectures. And the second one is compound rest method. This is also called as swivel method, which is very important as the exam point of view. And then we have taper turning attachment method, third one. And fourth one is form tool method and combining feeds method. So these are the 5 different types of methods which can be applied on a lathe machine to get taper turning. So far we have understood what is taper turning. It is an inclined turning process, and we should have some parameters. Any one of the 4 parameters should be given to get the taper. That means initial final diameters and the taper angle, or the millimeters of amount has to be removed for the length, etc. They have to be given. Okay. Or by any ratio has to be given in order to do the taper turning process. Then we have seen 5 different types of processes or methods by which we can get taper turning object. Okay, now let us see the first method, tailstock set over method. So this taper turning method is used only for taper turning of small top angles. Okay, only external tappers can be machined by this method. This particular method can be used to get taper turns that are used for small top angles only. So we have said already that we should have any one of the parameters out of the 4 by which we can do this taper turning operation. In this, we should have only small top angles are given. That is why it is called set over method. So initially the top angle has to be set over, and using that value we have to do the taper turning operation. Okay. Now see here, only external tappers can be machined by this method. Only external tappers. Suppose this is an external taper turning. So I have removed the material in an inclined manner. Sometimes I have to do this taper turning internally. Suppose if this is an object, I have to do this internal threading also, internal taper turning. So this operation cannot be performed by this tailstock set over method. So only external tappers are performed. In these types of taper turning methods, the tailstock is set out of alignment according to the size of the turning tapper. So in this method, the tailstock is set out as alignment. The tailstock plays a very important role in this process, depending on which we can do the required taper turn. Okay, the clamping mechanism is loosened for offsetting, adjusting the upper part of the tailstock as required. Now, these processes are very practical. They will be easy to understand when explained practically, but theoretically we will try to explain somehow, but practically they are more easy to understand. So see here, the clamping mechanism has to be loosened, and for offsetting and adjustment, the upper part of the tailstock as required. So the tailstock has to be offset. It should be prepared in such a manner that it should be loosed, and offsetting has to be done in order to get a taper turn. Okay, and adjustment screws are tightened, which is shown in the figure. So we can see here, this is the headstock and this is the chuck, and here we have workpiece. This is the workpiece. This entire part is nothing but the workpiece from here to here. Okay, this is the workpiece on which we are performing taper turning operations. And see here, we have to take the support. We have to take the support of this tailstock, but it is taken offset. It is not centered. See here carefully. The center point of the tailstock is not aligned with the center line of the workpiece about which it is rotating. So it has to be kept offset in order to get a taper turn. If it is kept at the center, we will get normal turning. We don't get taper turning. So in order to get this taper turning, we have to keep it offset. That means the tailstock has to be kept in offset with the workpiece. So by this, we can do the taper turning operation. So this is the tool which is kept here, So this tool is doing this tapering operation. See here, this cross section is taper cross section, taper surface which we got. So to do this, we have to align the tailstock offset to the center line of the workpiece. Okay, this is the key change that we have to do for getting the tailstock set over method. See here, we can simply call this as offset method also. Offset method, tailstock offset method. So in this process, for getting the taper turn, we have to align the tailstock in an offset manner. That means it should not be aligned with the center line of the workpiece. It should be kept offset. That's it. And then we have some parameters which are required to calculate the amount of material removed, etc. So this method is also called as offsetting tailstock method. We already said that. Offsetting tailstock method. For performing this method, ball center type work holding device is used in a tailstock. Okay. Ball setting type work holding device has to be kept in the tailstock. Generally, the tailstock will be in align with the center line of the workpiece. Okay. But in this operation, we have to keep it in an offset mode. So to do this, we have to keep the work holding device, that is ball center type of work holding device, has to be attached into the tailstock. So actual cylinder billet is to be removed from the tailstock, and we have to keep a new arrangement into the tailstock for making it offset. Okay. So for performing this method, ball center type of work holding device is used in a tailstock. The amount of offset is calculated in the following way. See here, this is the formula for calculating the amount of offset that has to be kept in order to get a taper turn. So see here, offset O is equal to taper multiplied by L. We'll see what are these, over 2000. So here taper is nothing but it is given in the value of millimeter per meter. So this value has to be given in the standards or the design. Okay, this value has to be notified from the designer so that we can fix this value in this taper formula multiplied by L. L is nothing but the length of the workpiece in millimeters. So it should be multiplied with the length over 2000. So 2000 is nothing but it is a standard value taken. By using this formula, we can calculate how much offset we have to keep. Okay, this O value is nothing but how much offset we have to keep the tailstock from the center line of the workpiece. See here in this picture, this is the center line of the workpiece about which it is rotating. We have to keep the tailstock with an offset value. So this value, it is calculated by this O. So this is the center line and we are keeping the tailstock here. So this distance, this particular distance is O. Okay, this is tailstock. This is the center line of the workpiece. So this O value is very crucial in determining the offset value. This offset value has to be calculated by the taper value, which should be given by the designer while designing. Okay, and then let us see the next process. So this is also a method by which we can get taper turning. We are currently studying taper turning processes by which different types of methods are there. 5 methods are there by which we can get a taper turning operation. So this is compound slide swiveling method. See here, on a lathe machine, we have headstock, tailstock, tool post, etc. Some parts are there. So far, we have always been using headstock for fixing the workpiece. Obviously, we don't have any other option. So headstock is used for fixing the workpiece. Now, in the first method, we have used offset tailstock method. Offset tailstock method for getting a taper turning. And then here we have tool post. That means we can change the position of the tool post in a particular way so that we can get a taper turn. So this is most popular method tool post swiveling method or compound slide swiveling method. This method is popularly used because it is very simple. We don't have to change any attachments in the tailstock, whereas we seen in the first method. We have to change the tailstock arrangement so that we can keep it offset. But in compound slide swiveling method, we don't need to change any mechanical parts of the lathe machine. We have to keep the compound slide or the tool post has to be rotated into an inclined manner. See here, in this picture we can see this is the compound rest or the tool post on which we can keep the tool. So generally it is in the vertical direction. It is like this. Okay, the tool will be like this. Here, see here, this is the cutting tool and the entire arrangement of the compound slide is inclined, where it is inclined with the center line of the workpiece. So it should be kept inclined. So the angle between these two, this center line of this tool and this is given by the designer. This theta angle is nothing but the taper angle. So taper angle theta must be given by the designer in order to get the required taper turn. Okay. So depending on the given angle, we will rotate this taper compound slide according to the given angle and we will do the turning operation. By simply switching on the motor, the workpiece will be rotating. The compound slide will be inclined where we can still give the feed. Okay. Initially we will start at this point. I will draw this larger. So initially, this is the workpiece. We will start at this point. Okay, some inner point we have to start at here, and then we will, because the compound slide is at an inclined angle. When we give feed, it will go in this manner. It will not go horizontally. It will go inclinedly, so that we will get the required taper turning. Very simple. So compound rest method, we will try to understand some more applications and parameters that are regarding the compound rest method. It is also called as swiveling method, compound tool post swivel method. So in this method, firstly, compound rest is set at a particular angle corresponding to the center line of the workpiece or a job. It is locked in this position. The compound rest is inclined at a particular angle and it is locked. It should not be rotating. Okay, it can be used to give feed, but it should not rotate. After the cutting tool is set exactly at the center and brought into position by carriage movement. Okay, the cutting tool is set exactly at the center and brought into position by carriage movement. When we want to give the feed, we have to move the carriage, not rotating the compound rest. We have to move the carriage in order to give the feed. So the carriage is then locked and the taper turning of the object is done by turning the handle of the compound rest by hand. So we have to slowly rotate the handle of the compound rest so that it will give feed, so that it will move along the taper length of the workpiece. Okay, and when we have to calculate the formula, so the compound rest angle can be calculated by using some kind of formula. If it is not given by the designer, we have 4 parameters. Out of these 4 parameters, any one has to be given. So depending on the type of method, we have to calculate the value. In the previous method, we should know the initial and final dimensions by which we can calculate the taper is given. It is the value. By using the taper value, we can calculate offset distance. By that, we can simply do the offset value calculation and we can do the offset tailstock offset method for getting the taper turning. In this method, we should need angle. The angle has to be calculated with the help of this formula. Tan theta is equal to d minus small d by 2 times the length. So here capital D stands for large diameter of the taper. That means if I draw the diagram, see here, this is the smaller diameter and this is the larger diameter, capital D, and the smaller diameter is small d, and L is the length of the taper, L. So by using this formula, we have to calculate the angle by which the compound rest has to be rotated. See here, tan theta is equal to capital D minus small d. That means larger diameter minus a smaller diameter over 2 times the length of the taper. So by using this formula, we have to calculate the theta first, that means the angle of a taper. By using this angle, we have to rotate the compound rest along this angle, and then we can do the operation by simply getting the taper turning. Okay, so that is all about different methods of taper turnings used. We have seen two methods, that is offset method, tailstock offset method, and then we have compound rest swiveling method. So these two processes are very important and they has to be studied with greater importance. We'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.